Today and for the next several days in class, we are going to be looking at adding and subtracting positive and negative numbers. So we are going to look at modeling integer addition today using counters. You should all have a bag of counters on your table. Please remember, these are tools, not toys. If you are flicking them, dropping them, throwing them, playing with them when you should not be, they will be taken away. Please do not open your counters or dump your counters out on your table until you are told to do so in the lesson. You should be listening and understanding how to properly use the counters, and then you will be told when to get the counters out yourself to do a problem. So as we begin today, we are going to look at some examples of how we model adding negative and positive numbers using counters. So here we have several examples. The first one is really simple. It is an example that we might have seen in first grade. We're starting with a simple example because it gives you a good understanding of how the counters are used for adding integers. So we have positive 4 and positive 5. When we are using counters, we use the yellow for positive numbers. So we are going to put out 4 positive counters and then 5 positive counters, all yellow counters. Then we can go back and count the total number of positive counters. Because there are 9 and they're all positive, our answer is positive 9. When we are doing negative numbers, we use red counters. Red counters equal our negative numbers. Yellow counters are our positive numbers. So we are going to count out our counters, but now they're all negatives because we're adding 2 negative numbers. So we have 6 negatives plus 8 more negatives. So we're going to count out 6. 1, 2, 3, 4, 5, 6. And then 8 more. 1, 2, 3, 4, 5, 6, 7, and 8. We have all negative counters, so our answer is going to be negative, and we have a total of 14. So our answer is going to be negative 14. Where it starts to get a little bit tricky is when we start adding a negative and a positive number. So on the next example, you see we have a negative 4 and a positive 5. This example is a little bit trickier because when we're done, we won't have all negative numbers or all positive numbers. So let's start first by simply counting out our counters. We have 4 red because we have 4 negative. 1, 2, 3, 4. Then we're adding 5 positive. So we're going to put 5 yellow counters. 1, 2, 3. We're going to move some from the first problem, 4 and 5. So we can't just count up our total number of counters because here we have some negative and some positive. So before we can count them, we have to have all negative or all positive numbers left to know if our answer is negative or positive. So to get rid of counters, we make 0 pairs. 1 red and 1 yellow make a 0 pair. I think about this as owing $1 and having $1. If I have $1, that's positive. If I owe $1, that's negative. So together, if I have $1 and I owe $1, I pay off what I owe, and now I don't have any money, but I also don't owe any money. So this makes a 0 pair, which means if it's 0, it's not anything. It's no longer part of our solution. So we are going to try and make as many 0 pairs as we possibly can, and then whatever's left will be our final answer. So here is another 0 pair. Here is another zero pair, and here is another zero pair. I am able to make 4 zero pairs. So now all of these counters are worth nothing because they're zero. So they are not part of our final answer. And whatever is left, which in this case is 1 positive, that is our final answer. So -4 plus +5 equals +1. Let's try another example where we are adding a negative and a positive number. -6 plus 2. Let's start by getting our counters. We're going to take 6 negative counters, which are 6 red counters. 4, 5, and 6. Then we're going to take 2 positive counters, which are 2 yellow counters. 1, 2. Next, we're going to make as many zero pairs as we can. There's 1 and there's 2. So those are not part of our solution. And what we have left is 4 negative numbers or 4 negative counters. So this is our final solution. We have -4. So -6 plus 2 is -4. What's really important to remember, especially when we are adding a negative and a positive number, is that we have to make zero pairs. The way we make zero pairs is 1 red and 1 yellow counter together. They equal 0. They cancel each other out. This is called a zero pair. So you have to cancel out one of your negative or positive numbers so that all you have left is a positive or a negative solution. When you have both positive and negative counters, you don't know what your solution is. You don't know if your answer is negative or positive. So now we are going to pause the video, and I would like you to turn and talk to either your partner or your group of 3. Have a discussion on, would changing the order of the numbers that you are, turn and talk to your group, either the partner that you sit with or the others at your group of 3, and I want you guys to discuss what you think would happen if you changed the orders you are adding the numbers in. So for example, if I am adding -2 plus 4, would my answer change if I was adding 4 plus -2? I want you guys to explain if you think the answer is no, why? If you think the answer is yes, why? Remember, you should not be talking about anything that is not related to this question. If your group finishes before time is called, you should be sitting quietly to let the teacher know that you are finished. Make sure that everyone who has something to input into the math conversation is heard and gets an opportunity to speak. We are going to pause the video and give you guys about 3 minutes to talk about this at your table. Please do that now. Hopefully, we have all had a chance to discuss question number 1 with our groups. I also hope that all of our groups understand now that the order of the numbers does not matter. This property is called the commutative property. When you are adding numbers, it doesn't matter what order you add them in. It doesn't matter if the negative comes first or if the negative comes second. As long as you understand that you are making zero pairs and putting together groups of positive and negative, they will still cancel each other out no matter if you put down the negatives first or if you put down the negatives second. The order only matters in subtraction, or if we're talking about multiplication and division, the order also only matters for division and subtraction. When it comes to multiplication and addition, we can use the commutative property, and order does not change the answer. So if you know the answer to -2 plus 4, you also know the answer to 4 plus -2. Now, I would like for you to do this again, except this time, I would like for you to talk about when can you move counters from an addition model. So if you're confused on what this question is asking, I want you guys to talk about when can you take out a counter from our solution so that we are only left with negative or positive counters in the end, so we know if our final answer is negative or positive. So this is just reviewing what we just talked about and giving you guys an opportunity to discuss it to make sure everybody understands. So again, give everybody an opportunity at your table to talk. And if you finish before time is called, make sure you turn off your voices so that the teacher knows you are finished. Please pause the video and discuss question number 2 at your tables now. So as a quick reminder, you can move counters out of your addition model when they equal 0. When you have one red and one yellow counter, this equals a 0 pair, and they can be removed or taken out of your addition model because they don't equal anything, and so they do not have a role in our solution. So remember, you can move counters out of an addition model when they equal 0. One red and one yellow counter together, one negative and one positive. So let's continue to practice and do a few more problems, but this time I'm going to let you guys try it first. So let's go ahead and do not dump out your counters. Please take the counters out of the bag as you need them. When you dump the counters on your desks, they get all mixed up, and some bags end up with a ton of counters, and some bags end up with not enough counters. So leave your counters in your bag and only take them out as you need them. I want you guys to try number 1 on your desk first by yourself. -8 plus -4. Use the counters to model, and then use your expo marker to write your final answer on your desk that you find by looking at the model. So look at the model. Even if you think you can do this without the model, I really, really, really want you guys to focus on doing the models. So whether you can do it without the model or not does not matter. Please do it with a model for today. If you get to the point where we know you can do it without, that's fine. But remember, your standard for 6th grade says that you will understand the model. And so sometimes on your state test, they will give you a picture using the counters, and you have to simply state what addition or subtraction sentence matches those counters. So today we are actually using the counters whether you need them or not. Please model number 1 on your desk and then write the answer with the expo marker. We're going to pause the video and give you guys a chance to try that now. Please do number 1 on your desk. So hopefully everybody had a chance to try number 1. It's a pretty easy one to get us started because we are adding 2 negative numbers and we don't have 1 negative number and 1 positive number. So I'm going to work it out for you up here just to make sure everybody has the correct solution and then we understand the solution if we got it wrong. So we're going to start by putting out 8 negatives. So I have 1, 2, 3, 4, 5, 6, 7, 8. So those 8 counters represent this first number in my addition sentence. So then I'm going to do this second number in my addition sentence, and I'm going to put out 4 more red counters because both of these numbers are negative. 1, 2, 3, 4. So I've got a little line separation here. So you can see my first group of -8 matches my first number, and my second group of -4 matches my second number. I have all red counters, so I can just count those counters, and that's my final answer. I don't have red and yellow. When you have both red and yellow, that's when it gets a little bit more complicated. So all of my counters are red, which means my final answer is negative. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 negatives. So my answer to the first problem is -12. The next one gets a little bit trickier because we are doing -4 plus 8. So we have one negative number and one positive number. Let's pause the video and try it on our desk. So hopefully everybody had a chance at this point to try the second problem. So let's go ahead and start by putting out our counters. So we have -4. So I'm going to start by putting out 4 red counters, which represent my negatives. 1, 2, 3, 4. Then I have +8. So I'm going to put out 8 yellow counters, which represent my positives. 1, 2, 3, 4, 5, 6, 7, 8. Squeezing in the 8 one here. I'm going to move them all over a little bit so that we can see all 8 of those counters clearly. So now I can't just count my yellow or count my red, and I can't count them all together because I wouldn't know what's my final solution. Is my final solution negative or positive? So now we have the complication of getting rid of counters. I get rid of counters by making 0 pairs until I cannot make any more 0 pairs. We make 0 pairs by having 1 red and 1 yellow counter. So I'm going to move my counters over here to make some 0 pairs. So this is 1 0 pair. This is another 0 pair. Here's a 0 pair. And here's a 0 pair. So all of these become zeros. That means they're not worth anything, so they're not part of my final solution. I have no more red counters, so I can't make any more 0 pairs because I have to have 1 red counter in a 0 pair. So these are the counters that are left, so these are my final solution. They are yellow counters, so my final solution is positive, and there are 1, 2, 3, 4. So my final solution is +4. We are going to pause the video and try the next problem. Be careful. Even though this looks like the same problem, this is not 8 plus -4, which would also have a solution of 4. This is -8 plus 4. It is not the same problem. It is a different problem, and it has a different solution. Please pause the video and try the next problem on your desk. So again, I hope you guys have all had a chance to try this problem, but let's go ahead and work it out together so that A, you understand your solution is correct, and B, if you got stuck, you see where you got stuck. So the first thing I'm going to do is I'm going to count out 8 negative counters, which is 8 red. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to count out 4 positive counters, which is 4 yellow. 1, 2, 3, 4. Now I'm going to try and eliminate by making 0 pairs so that I know whether my final answer is negative or positive. So this is 1 0 pair. This is 2 0 pairs. This is 3 0 pairs. And this is 4 0 pairs. So all of these eliminate. This is my final answer. There are still 4 left over, but look at the difference between our previous answer and this answer. There are still the same amount left over, but the color of the counters is different. And that makes the solution a completely different answer. A lot of times I hear, oh, I got +4, but the answer was -4. My answer was so close. Those answers are not close. That negative sign makes the answer completely different. So make sure that if the negative is part of your solution, that it's there and that it's clear. So this solution is -4. Very different from the previous problem. Hopefully we're all getting the hang of this, but I do have a couple more practice problems if there's time for us to continue practicing with whatever time is left in class today. So let's look at another problem. The next problem is -3 plus -7. Let's pause the video and try this problem on our desks. Okay, so hopefully everybody has had a chance to try -3 plus -7. I'm going to put out 3 red counters, 2, 3. Then I have a -7, so I'm going to put out 7 negative counters. 1, 2, 3, 4, 5, 6, 7. This one's pretty easy because we are adding 2 negative numbers, which means we cannot make any 0 pairs. All we have to do is count up the total number of counters. So we have 7, 8, 9, 10, and they're all negative. So our answer is -10. All right, let's try another one. Let's pause the video and try -9 plus 6 on our desk. Once again, I hope everybody has had a chance to try this problem, -9 plus 6. This one's a little bit trickier because once again, we have one of the numbers that we're adding being negative and one of them being positive, which means before we can come up with our answer, we are going to have to make 0 pairs. But let's start simply by putting out our counters. So I'm going to start with -9, which is 9 red counters, because remember our red represents our negatives. So I'm going to put out 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to do my 6 positives, which is 6 yellow because my yellow represents my positives. 1, 2, 3, 4, 5, 6. So the way I put those out, I put them out lining them up with a negative so that you can see without having to move them that these all create 0 pairs. So I will eliminate all of my positive numbers and I will be left with 3 negatives that do not have a 0 pair, that are not paired with a positive. So my answer is -3. So -9 plus 6 equals -3. Hopefully you guys are getting the hang of this. We have 2 more practice problems that we're going to try if we have time. So if you still have time left in class, let's go ahead and pause the video and try the next problem on our desk. -5 plus 7. So hopefully everybody had a chance to try -5 plus 7 on their desk. I reset my board a little bit and put my counters back from the previous problem because it kind of went into my space for the next problem. So now I have room to do the next problem. So I'm going to start by putting my counters out. I'm going to put out 5 negative counters. 1, 2, 3, 4, 5. And I'm going to put out 7 positives, and I'm going to line them up with my negatives so that I can see those 0 pairs. 3, 4, 5, 6, 7. So here I see that I have 5 0 pairs. So these are eliminated. And then what I have left are in positives, and there are 2 of them. So -5 plus 7 equals +2. So the last problem that we're going to practice today is -7 plus 2. Go ahead and pause the video and try this problem on your desk. So hopefully everybody had a chance to try this problem. Let's go ahead and work it out together. I'm going to start by simply putting my counters out. I have 7 negatives, so I'm going to put out 7 red counters. 2, 3, 4, 5, 6, and 7. And so now I'm going to put out 2 positives, and I'm going to put those out already lined up with my negatives so that I can see those 0 pairs. So I've created 2 0 pairs. Those become 0, and this is my solution. My solution is all negative counters, so my solution is negative, and I have 1, 2, 3, 4, 5. So my solution is -5. Hopefully you guys are starting to understand how we add integers using counters and starting to see some patterns on how these work so that you can start adding integers without using the counters. Tomorrow we are going to continue practicing adding integers, and we are going to look at how you use a number line to practice adding integers and how that visually helps us understand what we're doing when we do the steps of adding integers. I hope you guys are all doing a great job with this and it's making lots of sense, and I miss you, and I hope you're all doing well and behaving for your substitute. Have a great day, and I'll see you all soon.